As is common with a lot of things, I think universities are different. The government like to control what is taught, how it is taught, and when it is taught. So let's just have a look at when I can find it. This here. This is live, actual government site. We're talking about functional skills. Right, the cat just walked in and distracted me. So where are we? That's one of the subjects they like. Let's come down here. Like to look at is, see if I can find it first. There's all sorts of things they want you to look at. Percentage. Bear with me. Mixed numbers. There we go. Look, inverse proportions, direct proportions. We're going to be looking at this one here. I used that one, direct proportion, to work out the wage, salary, in the previous video. We're going to be looking at this one here. Now, first of all, let's think about the word inverse. I think I prefer white. What does it mean? Well, if we've got a value of, say, 3, the inverse of 3 is 1 over 3. So somewhere, if we have a value of x, the inverse of that is 1 over x. So somewhere in our calculation, we're going to get this condition here. That's what it means. Now, inverse proportion basically is 1 over some number that may change multiplied by some constant. Normally they use the letter k for that. Now that would, something would equal k times 1 over some variable there. We are going to be building this, and I will use my own example to demonstrate what it's actually doing. We will end up with that there. Going to go a little bit retro here. When I was young and at school, I never really did understand how this worked, and I kick myself now wondering why I didn't understand it. You didn't have diggers in those days, not in the sense of machines. You had people. So if you had a road, say, and something went wrong, there was a fault with the electrics or water, there'll be some poor bloke down there with a pickaxe, shovel and fork, digging the hole manually. Except normally it wasn't normally one, it would be perhaps 3 people, 3 fellas, 3 men. You never saw women do it in those days, right? So it's about digging a hole. This is going to be the focus of the question I want to use. Remember, this is the sort of thing that was done when I was a boy. They used different stuff now, for example, painting a gate. Okay, here we go. People of my age will remember this type of question. If it takes, what time shall we say, 18 hours, that's a long time, isn't it, for one man to dig a hole, how long will it take 3 men? Question mark. That's your question. So how are we going to deal with this? Now, the books I looked at weren't very good at their explanation, so I'm going to tackle this in a particular way, and you hopefully will be able to follow it. Suppose we have, going aside, different topic, we have ground there, and sitting on the ground is a big lump of metal, and it has a weight. Suppose it has a weight of, saying, 7 kilograms, and I want to push that along the ground, that distance, so I want to push it that way, and suppose that distance there is 3 meters. We need to be able to demonstrate or represent the amount of effort done to move it. We need to include the 3 meters in some way and the 7 kilograms in some way. Well, it's quite straightforward in as much as, think about square area. Suppose we have 4 centimeters by 3 centimeters. What we do is we multiply the numbers together, 4 times 3. Right, that's that. We then multiply the units together, and I'm going to put a multiply there. I'm not going to explain why, but it is correct. Centimeters times centimeters. So we multiply the units of measurement together. Let's multiply the units of measurement together. So we have 7 kilograms times 3 meters. So that becomes just the numbers multiplied together. Then the units of measurement multiplied together. So we end up with 3 sevens of 21 kilogram meters. That is the crunch. That is a sort of artificial way of combining those numbers. So in this question we have initial condition. Initial, I'll put COND for condition. Alright, initial condition. 1 man and multiply together takes 18 hours. That will give me, using what I just said, 1 times 18. Alright, I'll write it, look, 1 times 18 times man hours. If you like, I can do MH. Alright, MH, man hours. So we have 18 man hours. That is our initial condition. That represents the amount of work needed to dig the hole. So the work needed to dig the hole is 18. I'll write the words. Okay, that's the initial condition. How long will it take 3 men? Well, look, we have the amount of work is the count of men multiplied by time equals work done. So we have, in the new condition, 3 men. We don't know what the time is they'll take. We want to find that out. But we know that the amount of work they got to do is 18 man hours. So 18. Now this one here, I'm going to use units of measurement. I've seen books do this without using the units of measurement. It is extremely important because it helps understand what is happening. Now we need to find out what that is. How many hours? Shortcut method, you should know by now. Want to take that over the other side because you want this to be on its own, so we need to get rid of that. What is influencing that is multiply. Take it over the other side, and the action is the reverse of this. The reverse of multiply is divide. So we have question mark hours equals 18 man hours. Draw the line. Take that over the other side and it becomes divide. 3 man or men. Now units of measurement can cancel out. This is where the inverse comes in. 18 man hours times 1 over 3 men. That is the inverse bit. Inversely proportional to. So that was our x and that was our k. That is the constant. That's the amount of work that needs to be done. Okay, so we now just simply work that out. So the amount of hours needed for 3 men is 3 into 18, which is 6. The man part of the units of measurement cancel out. The only unit of measurement left is hours. And I'll put in the whole word. That's it in a nutshell. You will need to watch this a number of times. Now I'm going to go on and give you an example of the type that I saw in the book that I got. Now I'm going to change the numbers a bit, the sort of thing I saw in the book. Example 2, we've just looked at example 1, we're now looking at example 2. Imagine you're a bird flying up in the sky and you're looking down and there is a square pond of some unknown size, and feeding into that pond is 2 hose pipes, and it takes 2, I'll use just hose, 2 hoses, 6 hours to fill the pond. So the amount of work done is 2 times 6, which is 12, and the combined units are hose hours. So that is our initial condition. How long would it take for 10 hoses? Silly, I know, but I only have 1 hose to water my garden. That's your question. Initial condition, 2 hoses, takes 6 hours to fill that, so the amount of work done to fill it is 12 hose hours. Very important that you really get to grips with this combining of units of measurement. So we want 10 hoses. I'll use the singular, look, that times that, and there's a time there, times some unknown hours equals 12 hose hours. We want that on its own, so we want to get rid of that. So we do that by taking it over the other side, shortcut method. That is multiply, so when we take that over the other side it becomes divide, so we end up with the unknown hours. That now has gone from the left, 12 hose, hours. Take that over the other side, it becomes divide, which is the same as multiply by 1 over 10 singular hose. The inverse, inversely proportional. Now look, hose, unit of measurement, hose, cancels that. The only unit of measurement left is hours, so the unit of measurement on the right now matches the unit of measurement on the left. So we've got the question mark hours equals 12 over 10 hours. So look, that 12 divided by 10 is 1.2 hours. Now you can change that into minutes and seconds if you want, but I wouldn't bother. It's just demonstrating the method. Once you get to grips with it and understand how the units of measurement are working and how everything is interrelated, you can apply the stuff you already know about algebra manipulation or equation manipulation, and you've got your answer. Fairly straightforward, but it's getting to the point where you believe in yourself that you can do it, you understand it, feel confident about it, then it becomes straightforward. Until you reach that point you think, oh my goodness. But watch it, do it a few times, you know, have a go with some.